so here is your happy minute for today. It says sketch 5 pi over 2, then find its reference angle. No, since I'm working it with you, it's not time. But it will be 4 minutes this week. Okay? It'll be 4 minutes this week when I do turn it over to you guys. But today and tomorrow, I'm working it with you, but you guys are going to walk me through this. Okay, because I want to start out, the third 6 weeks with some really good grades. I want to make sure that everybody's on the same page. And, we're going to be doing this through next week. So, yes, sir.
Isn't that like 90 degrees?
There you go. That's exactly right. This one, just like on Friday, let me go ahead and get a grid going here. This is a quadrantal. Yes. Hello. Okay, so Christian, if you'll take out a piece of paper, we're working on our happy minutes. All right, so Angel already helped me out with this. Now, it definitely is a quadrantal. It's going to end up on one of these axes here, but which one would it be? Okay, the positive y-axis. If we were to do like we normally do, if we took this improper fraction and rewrote it as a mixed number, how many times will 2 divide into 5? 2 and 1/2 pi, right? So we have pi over 2, this is pi, 3 pi over 2, all the way back around to 2 pi, and we always start at 0 radians. Well, the 2, remember 2 pi is always 1 revolution. So we get all the way back around to where we started, but then now I only want to go an additional 1/2 pi. So you guys are absolutely right. This is going to put me on the positive y-axis. Now, if it's a quadrantal, remember, you won't be creating a right triangle. We won't be coming up with a reference angle of 30, 45, or 60. And we'll go ahead and review those tomorrow. This one here, the reference angle is 90. Yes. By definition, the reference angle is always created using the terminal side where we stopped and the closest x-axis. Well, in this case, whether it's positive or negative, it's the same thing. So I want to go ahead and put reference angle. I'm going to go ahead and say 90 degrees. Or if you want to put pi over 2, that's fine, as long as it's equivalent. Okay. Now, because we're not creating a right triangle, we have to be using the ordered pair at that location. So the ordered pair we have here is 0, 1. Okay. Now we have all the information I need. I want to go ahead and start to look at the 6 trig functions. So what's first? Sine. Okay. And for each one, I'm always going to plug in the measure that I'm evaluating this at. So sine of 5 pi over 2. But help me out. What is sine 1? Okay, sine always wants the y value. In my coordinate here, I have an x and I have a y. Sine wants the y, so what's sine of 5 pi over 2? 1. Okay. Now what? Now cosine. Let's do cosine of the same location. But this time cosine wants the x value. So I'm going to go ahead and put 0 because the x value of that coordinate is 0, just like the y value was 1. Now we want tangent. But I'm going to go ahead and write this out. Tangent of 5 pi over 2. Tangent wants what ratio? Tangent always wants y over x. There we go. Now, would it be 0 or undefined? Undefined. I'm going to take the y value of 1, divide it by the x value of 0, but we cannot divide by 0. So here you could put the 0 with the slash for it like I did. You could actually write no solution. You could write undefined. Any of those would be perfectly fine. Okay. Anything divided by 0 is undefined. Yes, ma'am. Okay. Now, see, we're already halfway there. What would be next? We could go cotangent if you wanted to. Okay. Cotangent of 5 pi over 2. Now, if tangent is always y over x, then cotangent is x over y. So the x value 0 over the y value 1. Now 0 divided by anything is 0. There's only one exception. 0 divided by 0 is undefined as well. There wouldn't be a solution there. Okay, now let's do cosecant. Let me go ahead and give myself a little more room here. Cosecant of 5 pi over 2. Now, give me the ratio in terms of x, y, and r that cosecant wants. It's always r over y. But now, if you come across a ratio that has r, remember, we're on the unit circle, so what's r? It's always 1. There you go. And the y value, again, out of that location is just 1. So 1 divided by 1 is just 1. And that makes sense because what's the reciprocal of 1? Yeah, 1. Okay. And we have 1 left. What is it? Secant. So secant of 5 pi over 2. Now, if cosecant wants r over y, then secant wants r over x. So the radius is still 1, but the x value is 0, and we can never divide by 0. So I cannot evaluate secant at this location. Okay. Now, even if we were to go ahead and start plugging some of these in the calculator, we're going to go ahead and get the same thing. Now, my calculator's in degrees, so why don't we go ahead and take 5 pi over 2. How do I convert that to degrees? There we go, 180 over pi, because we want those pi's to cancel. So 180 over pi. So the pi's are gone. How many times will 2 go into 180? Okay, 90. There we go. And then what's 90 times 5? 450 degrees. So let's plug some of these in and actually see if we're correct. Like, for example, if I take sine of 450 degrees, which is 5 pi over 2, it's just that my calculator is in degrees, not radians. So the sine of 450 degrees gives me exactly what we just figured out. Let's even take one where it was undefined, like tangent. Let's say tangent. Remember, right here next to 7, tangent, 450 degrees. See, it tells me we can't do that. Okay, undefined. There we go. And if we were to plug in any of the other ones, we would get the exact same results. Again, you just have to make sure you know what mode your calculator is in. This is what the happy minutes are going to be rest of this week, next week as well. But tomorrow, we're not going to be on a quadrantal anymore. We're going to be one of those 12 in the 4 quadrants. So you will be creating a right triangle with the reference angles. But again, tomorrow, I'm going to help you through that one again. We're going to practice. Make sure you guys feel really good about this. All right, let's pass those up to the front, please. Those are the happy minutes for November the 5th, 2018. Thank you, thank you, thank you. Thank you. All right. Okay, thank you, thank you. Yes, ma'am. We are almost done with that packet. We're very, very close. Okay, so I got them all? All right. Okay, so just a couple of items before we go ahead and get started. Next Friday is going to be the last day before we go to our first vacation, the 16th. But before we get there, next Thursday, the 15th, is when we're going to have our first exam. We're going to go ahead and do it right before the vacation. I would rather do that than have it right when we come back after vacation, because I'm not going to assign you guys anything over Thanksgiving break. We're all going to take a little vacation, recharge our batteries, come back, and start looking at some inverses and identities. So that's coming up next week. This Thursday, in 3 days, on the 8th. Okay. Oh, excuse me. Yours is going to be on Friday because your homework is going to be due on Thursday. That's right. So I'm going to give you homework tomorrow. It'll be due Thursday. You'll have a couple of days to go ahead and take a look at that. You'll even have some class time to work on that together as well. So your quiz on our current lesson, yours is going to be Friday. So we're going to finish the week with a quiz over law of sines and cosines. And hopefully by Friday as well, we're going to be able to start looking at the graphs of sine and cosine. All right. So help me out here. We've been talking about law of sines and law of cosines, right? Yeah. So law of sines was just a proportion. It was sine of angle A over side A equals the sine of angle B over side B equals the sine of angle C over side C. Remember, the lowercase letter represented a side length. The uppercase letter represented the angle measure. Okay. Now remember, in order to use the law of sines, you have to have a what? A pair. What does that mean? There you go. You have to have an angle and the side length directly across from it. Okay. If you don't, that's where the law of cosines comes in. Did we make it to this problem on Friday? No. We did not. Good. Then this will be the perfect one to start with. So let's take a look at this one right here. It says round side lengths to the nearest whole number, angle measures to the nearest tenth. Okay. So this one, I can't immediately go ahead and figure out the other two angles, okay, because I have no idea what they are. If I knew another one, I could find one by the sum of 180. Could I even use the law of sines? I don't have a pair. So I have an angle measure, but I have no idea what the side across from it is. This is where the other law comes into play. What is that? The law of cosines. So why don't we go ahead and start by writing it out. Now, I'll go ahead and write it in terms of the variables first. Remember, across from angle B is side B. Across from angle C is side C. We have no idea what A is. So let's write it out in terms of side A. Now, what was the first thing I did to the side? We squared it. Okay. Equals. Now, what did I do to the other two sides? So that would be B squared plus C squared. There you go. So you want to square the other two sides and add them. There, then minus 2 times their product. Minus 2 times B times C times the cosine of angle A. One of the patterns we noticed about the law of cosines, whatever side you start with, you finish with the opposite angle. Okay? So side A, we ended up with angle A. Now, we have everything we need to go ahead and find side A. So I'm going to say A squared equals. Now, the other two sides are 12 and 14, so I'm going to say 12 squared plus 14 squared minus 2 times B times C, so 12 times 14 times the cosine, and this time I even know the angle measure, 39.4 degrees. Okay. Now, normally, when we're working backwards and we're trying to find the angle measure, we got to move some things around so that we can plug it in the calculator. But what do you notice about this one? Yeah, I mean, you've already got it solved for the variable you're looking for. I don't have to manipulate anything. Well, let me take one step back, maybe one thing. This would give me A squared. I want what? A. So what would I need to do? I got to take the square root. Now, remember from last week, we're looking for a side length. So will I have to take the inverse? No. Only take the inverse of a trig function if you want an angle measure. All right, so I'm just going to go ahead and plug this in the calculator, and let's see what we get. So control x squared is going to give me my radical. Let's see, we had 12 squared plus 14 squared minus 2 times 12 times 14. Then I'm going to hit the trig button right next to 7. We wanted the cosine. I want to say 39.4. Is that right? Okay. All right, so I just typed my expression in the calculator. Remember, the calculator is going to take care of all that for me. So it looks like I'm getting 8.96. So I'd probably go ahead and say 9. Okay, 9. Okay. Now, by finding that side, I have given myself a what? I can go ahead and find myself a pair. But here's the thing. Okay. What do we know about these two angles here, the missing ones? Would one of them be obtuse, or would one be acute? Or let me ask you a different kind of question. Which one would be the largest, B or C? How do we know? There you go. So angle C would definitely have to be the largest because it's across from the largest side, right? Now, I really didn't go into this last week. If you were going to go ahead and find an angle measure using the law of sines, don't use it for a possible obtuse angle. Sine inverse is only going to be able to give you an acute angle. So if this guy is actually larger than 90 degrees, we're going to have a little bit of a problem. Okay, so we can do one of two things. I could use the law of cosines to go ahead and find C, or I could just use the law of sines to find B and then go from there. Because I know that B would have to be what? Would it be acute or obtuse? Have to be acute. There's only one possible angle that could be obtuse, and it would be this one right here. So we just want to be very careful. So what would you guys like to do? Do you want to immediately find angle C using the law of cosines or find angle B using law of sines? Let's find B. Okay. So let's see here. B. I'm going to go ahead and say sine of 39.4, bless you, over the side across from it, 9 that we just found, equals. Now, what would the ratio be if I want angle B? Sine of B, because remember, B represents the angle over side 12. Okay. Now, how do we solve a proportion? You cross multiply. There we go. So I'm going to have 9 times the sine of B is equal to 12 times the sine of 39.4. Divide through by 9. Okay. So that sine of B should equal 12 sine of 39.4 divided by 9. Right? Okay. So let's see what that expression is going to give me. Control divide. 12 times the sine of 39.4. All divided by, what was it? 9. Okay. All right. Now I'm getting 0.846307. So let me say 0.8463. There you go. So sine of B is 0.8463, right? I just rounded it so I could write it on my paper. If you're looking for an angle measure, you have to take the inverse. So I'm going to say the inverse sine of that 0.8463 that I just found, and that's going to give me the measure of B. Okay. So let's see if I can get the same value that Brandon is. So once I hit trig, sine inverse is the second row. I'm just going to highlight the previous answer, put it in. Did you say 57.8? That is exactly what I'm getting. So I know that this one is 57.8 degrees. And see, now I don't have to do anything fancy to figure out the last one. I just go ahead and subtract. So I'm going to take 180 minus the 39.4 minus the 57.8 that we just found. And I'm getting 82.8. Okay. So if I had actually used the law of sines to find C, would it have turned out okay? In this case, yes. But you just have to be careful. If the angle you're trying to find, if you suspect it may be obtuse, you don't want to use law of sines on it. Law of sines, the inverse sine function is only going to be able to give you an acute angle. If it's larger than 90, it's not going to be able to help you out. Okay. And there we go. Let's try another one. Solve triangle MNP. If M equals 54 degrees, N equals 17, and P equals 12. Okay, so let me give myself a little bit of room here. So I'm just going to draw my standard oblique triangle. So it's MNP, so I'm going to say here's MNP. So we don't know what side M is. We do know that M is 54. We know that N is 17, and we know that P is 12. Let me make that so it doesn't look the same. There we go. Capital N. Okay. That's a little N. Lillian. Okay. So let me ask you a question. Can I use the law of sines? So why not? There you go. There's no pair. I mean, I have an angle, but I don't know the side across from it. Okay, so I have to use the law of cosines. What do you suggest I find first? Okay, so Brandon, help me out. Write out my equation that's going to help me. Okay. Okay. So I take the sum of the squares of the other two sides. Which is 54 degrees, right? Okay. Now this one's actually pretty nice to us, just like the previous one. Will I take the inverse? No. For a side length, no inverse. For an angle measure, yes. Now just like we did for a squared, we're going to take the square root of the whole thing. So I'll immediately be able to figure out what M is. So back to the calculator here. That's not what I needed. Escape. Come on. Document B. There we go. So let's see. One big radical. What were my links? 12 and 17. Okay. So 12 squared plus 17 squared minus 2 times 12 times 17 times the cosine of, was it 54? So what should I be getting as soon as I push enter? I'm getting 13.9. Okay. Oh, okay. So we forgot to take the square root. There we go. All right. So 13.89. I'd feel comfortable saying that's just 14. Okay. All right. Now here's the thing. We got a pair, right? Across from 54, I got 14. Whatever units it is we're doing here. Now, do we want to stick with the law of cosines or go back to law of sines? Now, if we're going to go back to law of sines, we just want to be careful. Could one of these two angles be obtuse? Which one? So, because it's across from the largest side, right? So we don't know for sure, but because n is across from the largest side, there is the possibility that this could be obtuse. So to play it safe, what angle should we find next? I'd probably go for P, because guaranteed P would have to be acute if n does turn out to be the obtuse. Even if n is acute, we're still safe. So give me a proportion that'll help me find P. So sine of 54 over 14 over 12. Good. Will I have to take an inverse here? Yes. Okay, we're finding an angle. Is everybody okay with how I set up the proportion? Now, cross multiply. Yes. Oh, because 12 is across from that angle. Just like across from 54, see, we have the 14. So look for the side that doesn't create the angle you're coming from. Okay. All right, so this would give me 14 times the sine of P is equal to 12 sine of 54. Now what? Okay, divide through by 14. Those are going to cancel. So let's figure out what that is. 12 sine of 54. Control divide. Let's see. 12 sine 54 divided by, it was 14, right? Okay. So here's what sine of P should equal. 0.6934. Okay. And what do I do to find P? Got to take the inverse. So sine inverse of the 0.6934 is going to give me that angle P. All righty. So let's see what that is. Back to trig. Sine inverse. Highlight the previous value. I'm getting about 43.9. So I'd probably just go ahead and say what? 44. 44 degrees. Now let's see if the other one's going to turn out to be obtuse. I'm guessing no. So 180 minus the 54 that we had minus the 44 that we just found, I'm getting it to be 82. So it was not obtuse. Over 90. If it's over 90, then it's obtuse. If it's less than 90, then it's acute. Okay. There you go. So see, even if we had, like on this problem, just like the previous one, if I'd used law of sines to go ahead and find angle n first, here we would have been okay. But had that angle turned out to be obtuse, inverse sine would not have been able to help me with that. It's just one characteristic of that function. Okay, so you just want to be very, very careful about that. Yes?
Would it the inverse help if it was obtuse?
Because the inverse trig function is only going to be able to give you the acute angle that supplements to the obtuse angle. So let's say, just for argument's sake, okay, it's kind of a what-if scenario. Let's say we had gone through, we'd chosen to find this one next. And let's say this angle is going to turn out to be 105 degrees. But we set up everything the same way. I'm going to say sine of 54 over 14 equals sine of n over 17. So I run through the whole process. So sine of n would equal 17 sine of 54 over the 14. So now I'd go ahead and take the sine inverse of it, right? Sine inverse of that expression. Okay. Well, this is one of the characteristics of sine inverse. If the angle you're looking for is obtuse, he will not give you that obtuse angle. He's going to give you the acute angle that supplements to the angle you need. So what does that mean, supplement?
Like the leftover.
Yeah, so I would add that value and get what? 180. So what do I add to 105 to get 180? So this would give me 75. If you realize that. If you realize that that angle should be acute, or excuse me, should be obtuse, then you just go ahead and take its supplement. But see, that's why, so you don't have to remember that and worry about it. Just always think about, could that angle possibly be obtuse? Because if it is, sine inverse will not be able to help us with that. Okay, good. Good. How we doing? Okay, excellent. I'm glad you asked that. Okay. Now, there's a special case that we call the ambiguous case. It's called the side-side angle. So if you have two sides and the angle of a triangle given, sometimes the measurements are so perfect that you can create two triangles using the same measurements. Okay, it's just that one of them is going to turn out to be obtuse, while the other one's going to be acute. Now, this table that I put together just breaks it down for you and tells you, based on what you see, what are you going to have? Will it create a triangle for you? Will it give you one? Will it give you two? Or will it not give you any triangles at all? Now, you'll notice a couple things here. The top row is if the angle you're given is what? If it's acute, okay? Or if the angle you're given is right or obtuse. So just based on the angle you're always provided, you're going to know, okay, am I in the top row or the bottom row? Okay. Now, the two sides that you're given, if it's in the bottom row, you're just going to compare them. If side A is less than B, there's no triangle that can be created with those measurements. If A is greater than B, you're going to have one solution. Now, the only time you can ever come up with two solutions, it has to be a specific case. Side A has to be less than side B, and A has to be greater than H. What do you think H represents? The height of the triangle. Okay, so that's one thing that we'll need to go ahead and figure out. We need to find the height of that triangle. In fact, you'll notice, look at the other scenarios here. A is less than B, A is less than B. So if you're in the top row, you really want to know what the height's going to be. Okay, if you have an acute angle, you're going to want to know what the height is. So let's go ahead and put this into practice. This table is yours. Remember, you can use your notes. You by no means have to memorize this. But let's go to an example. Okay. Given these measurements, if I'm given one angle of 63 degrees, the side across from it is 18, and the other side is 25. Okay. Now, for consistency, I would say the easiest way to learn this process is to always go ahead and draw your triangle the same way. Okay. Just start with a triangle like this. You're going to be given an angle measure. Always put that angle measure on the bottom left. Okay. You're going to be given a side length across from it. And then the other side length, don't make it the base of the triangle. Make it the other top side. Okay. Always create your triangle like this. Now, one other thing that's going to be really useful to you, do you notice anything about the side angle I'm given? That's exactly right. Every time you have one of these problems, one of the sides given will be across from the angle that you have. So see, that's why Genevieve was asking just a second ago, well, why didn't they go ahead and connect that triangle over there? Well, that's what we have to answer. Could a triangle be created using this information? Okay. Well, let's go ahead and start to break it down. Remember, there are two parts to the table. You're in the top row if the angle's acute. You're in the bottom row if it's right or obtuse. Okay. So what do we know about this angle? It's acute. So I'm going to come back over here. There's no way it can be one of these scenarios. It has to be one of the four up top, right? And now remember, if you're in the top row, what's something that's really useful to have? The height. Okay. So let's go back over here and let's look for the height. So all you're going to do is from that top angle, just drop a perpendicular segment that we're going to call the height. Now see, we're creating a right triangle, so I can use that right triangle trig to help me out here. Let's say 63, but what would h and 25 be with respect to 63? What trig function would use that? Sine. Because what would the height be to 63? It'd be the opposite. 25 would be the hypotenuse across from the 90-degree angle. So I'm going to say sine of 63 is equal to the opposite height over the hypotenuse 25. Now, it's been a while since we've seen one of those, but how do you solve one? How would I solve for the height? Yeah, just times 25, right? Okay. So the height would be 25 times the sine of 63. Okay, let's go ahead and see what that is. Let me get rid of all this other stuff. 25 times the sine of 63. So let's say 22.3 units, whatever that is. Okay. So this height here is 22.3. All right. Now, we know we're in the top row, so let's go ahead and look at our lengths. How does A compare to B? Is A less than, greater than, or equal to? A is less than, right? Okay. Because 18 is smaller than 25. Now compare A to the height we just found. Is 18 smaller than, greater than, or equal to 22.3? So it's smaller than, right? So we know we're in the top row. You're going to want the scenario that has these conditions. So I'm going to look up at the table here. So A is less than B. A is less than H. So there is not a triangle that can be created using these measurements. Okay. It's not bad. The only new aspect here is just the table. The table is just designed to help you figure out how many triangles you could have, if any. So if there was exactly one triangle, then A would be less than B, and A would equal the height. If A is less than B and A is greater than the height, that's when you're going to have two solutions. Now, let's just go ahead and say this for argument's sake, right? Let's say that you didn't worry about the table, that you just pushed ahead just to see what would happen. Okay. Well, I'm going to create my triangle here. All right. I'm always going to put the angle in the bottom left corner, 63 degrees. The side across from it is 18. All right. And the other side, I'm always going to make this top portion. So that means angle B would be here and C would be here, right? Okay. So let's say I didn't worry about the table. I just went ahead and pushed forward with the information I have. Well, what angle could I find? Couldn't I find B? Okay. Because I have a pair, right? So I could say sine of 18 over, oops, it's a Monday, sine of 63 over 18 equals what? Sine of B over 25. Okay, now how do I solve a proportion? Yeah, so would you guys be okay if I just went ahead and put sine of B and then got the expression? So what would be up top? 25 sine of 63, and it would be over 18. Okay, so let's see what happens. I'm going to come on over here. Control divide. It was 25 sine of 63 divided by 18, right? Now this is what sine of B equals. So will I take the inverse? Yeah, if you're looking for an angle measure, you're going to have to take the inverse, just like we've been doing. See, even if you're not using the table, if you just go ahead and push forward, at some point, if the triangle isn't there, you're going to come across some kind of error message. It lets me know, okay, I can't find that angle, so there can't be a triangle that fits these dimensions. Okay. Any questions on that? No? No? Okay. Well, let's try another one. Okie dokie dokie. Let me go over here first and erase this. Okay. So let's say we have this triangle right here. And see, I can always draw a triangle that has those values, but the question is, if I were to actually measure them out, would it connect? Okay, so it's giving me this triangle here. It says A is 105, okay, side A is 73, and side B is 55. Okay. Well, immediately, what type of angle am I given? It's obtuse. So if I come back over here to the table, all right, all four of those are out. Because A is obtuse, it has to be one of the bottom two solutions, I'll say, the options. So the only thing I have to do here to figure out is A less than B or is A greater than B? Well, let's see, how does A compare to B? 73 and 55. So A is greater than B, right? So according to this table, what's going on? A is greater than B. So yes, a triangle can exist with those lengths. So now that we know the triangle can exist, well, we would just figure out what it is, exactly as we've been doing, using either the law of sines or the law of cosines. So is everybody starting to understand the table?
Yeah.
Okay, that's all the table is. It's just broken up into a couple of rows and scenarios to help you figure out, do I have no triangle, one triangle, or two? Okay, and now we just solve. What would you solve for first? I'd probably solve for B. Okay, so sine of 105 degrees over what? 73 equals sine of B over 55. Oh yeah. Cross multiply. Somebody help me out. What would sine of B equal? What's the expression? 55 times the sine of 105 all over 73. All right, so let me go ahead. Now, here's one thing you could also do, and some people out there might be thinking about it. You know how we've always been typing in the expression and then we take the inverse? Well, what if I just took the inverse and typed in that expression? Wouldn't that be just kind of taking one step out of it? Okay, so we could absolutely do that if we wanted to. So let me try that. So I'm just going to go immediately to sine inverse. Whoop, wait, and I hit the wrong one. Sine inverse, control divide, but I'm going to type in that expression that we have, which is 55, not 555, sine of 105, and I believe it's over 73. So see, this expression right here, we're not going to know what its decimal value is, and really, does it matter? No, because I'm going to plug it in sine inverse, and see, we are getting an angle measure. But if you want to go ahead and find the value of that and then take the sine inverse, whatever is comfortable for you. Okay? So let's say 46.7. Okay? So let's say this angle measure is 46.7. Okay? Well, how in the world am I going to find C? Yeah, now we just subtract. So I'm going to take the 180 minus the 105 that we already had, minus the 46.7 that we just found. Oop, forgot the minus. There we go. And when I push enter, I'm getting 28.3. Okay. So this is 28.3 degrees. And there's only one thing left for me to find, and this problem's done. Yeah, we just got to find side C. Now again, we have two pairs now. 105.73, 46.755. Either of those are going to find C for you. Personally, I like to always just stick with the pair I started with. Okay, so I'm going to say sine of 105 over the 73. So what should it equal? But do we know C? 28.3 over what? Little c. Will I have to take an inverse here? No. Remember, if you're looking for a side length, no inverse. If we're looking for an angle measure, we need the inverse. So here's C. What would be in the numerator after I cross multiply and divide? So 73 sine of 28.3, right? Over sine of 105. Okay. And now we just need to type it in and see what expression I get out of that. 73 sine of 28.3. Let's see here, control divide. 73 sine, was it 28.3? Over the sine of 105. Okay, so what should the length of the base of the triangle be? Okay, 35.8, so I'd say 36. Is that what everybody's getting? And this is it. Okay. See, we're still solving the triangles exactly as we have been. It's just that the table kind of helps you out with this one case. It's a very special case. What do you guys think? Okay. It just takes a little bit of practice. We'll be okay. We're going to practice again tomorrow. Okay. All right. So thank you very much, guys. If I can get your calculators back up to the front, please.